inspiring action.
You're tuned into the all-new Action One Network. Turn up your volume.
All right, so thank you everybody for tuning in here. Obviously, SG2 on Space. Today is the 53rd episode, actually. If we're going purely by the fact that it's been just about every week, it's been over a year now. Action One Media, right here, lovely studio. We are a1.com. The show itself, you can find me or us at facebook.com/The Shen Show. That's my name, SHEN. Or you can also go on YouTube and look up SG2 on Space. So before we get started, I would like to say please also support me at patreon.com/SG2 on Space. That's 2 with the number 2. SG2 on Space. And got a couple of tiers. Asteroid tier, $5. Moon, $10. Earth, $30. Mars, $50. For the Mars one, you will be able to actually have a promo on my show in terms of an ad. So that would be great if you're interested in that. And the other ones, obviously, you get recognition. So please consider doing that. So, yeah. Otherwise, it's just coming from my own pocket for the most part. So, once again, that's patreon.com, patreon.com/SG2 on Space. So today's topics, I figured we'd do about, how about the sun, the star up there. Well, I can't really point because it's nighttime, but you know, it's always there. But before we get started, why don't we talk about our current calendar of events that's coming up in terms of both astronomical and aerospace related. So in Houston right now, today concludes actually SpaceCom 2019, which unfortunately I was unable to attend. That was at George R. Brown Convention Center. I think I will cover more of it in our next episode, which, by the way, would not be next week live because it's Thanksgiving, but the week after that. So the SpaceCom 2019 is, I should say, since it's every year, one of the largest commercial space conferences in the country, and it's where NASA, aerospace, and industry, basically commercial companies and NASA come together, and they have a bunch of talks, exhibitions, and so forth. So that concluded today. It was 2 days. It was Wednesday, November 20th, and Thursday, November 21st. When I say today, obviously, I'm assuming you're watching live. So there's some other cool stuff coming up, though. There's astronomy workshop, planetary formation workshop, which I thought was interesting. That is coming up at November 25th, 26th, 27th, and 28th. So 4 days. And that is going to be in Tokyo, Japan. So good reason to go there if you are inclined, or if you're already there in that area. So it's NOJ Science Workshop, the second one, which is supported by the Division of Science and part of the National Astronomical Observatory of Japan. So if you want to learn about planetary formation, or you got a talk, or you're in that field, consider going, right? So it talks about debris disk, formation of planetary systems, etc. All right. Closer in here to Houston, I thought this was really interesting. There's the first International Orbital Debris Conference here in Sugar Land, Texas, which is pretty close to Houston. It's December 9th through the 12th, 2019. The prices are a little steep, even for students with early registration. It's about $290, and professionals $415. But it might be worth it, right? So this is going to be at the Sugar Land Marriott Town Square, starting in the morning of December 9th, and I think half day December 12th. And what is the goal of this conference? It is to highlight orbital debris research activities in the U.S. and to foster collaboration with the international community. So this 4-day conference will cover all aspects of micrometeoroid and orbital debris research, mission support, and other activities. It really does seem kind of pretty interesting. If you want to sign up for the conference or just to take a look at it, you can go to hou.usra.edu/meetings/orbital debris, that's DEBRIS 2019. All right. So yeah, consider attending if you're in that field or if you're interested. It's sponsored by AGI, which is a aerospace software company. All right, that makes this trajectory software. That's one thing I know about them. So orbital debris here in Houston, you know, we actually have NASA JSC is known for it is orbital debris programming office actually. So we have one here that tracks it. So you know, their scientists, engineers actually track orbital debris modeling and so forth. And if you're interested in that, that might be pretty cool. Check out this website, orbitaldebris.jsc.nasa.gov. Okay, so, and I believe, I would assume a number of NASA scientists from there would also attend this particular conference on December 9th through the 12th. Okay, in Sugar Land, Texas. So that's cool. If you're out in the West Coast or you're willing to travel, there is a gigantic American Geophysical Union, the 100th conference, so it's going to be huge, especially. They've been around for 100 years. That's December 9th through the 13th in San Francisco, California. So it marks the centennial in 2019. You know, so it's pretty cool. What is AGU? Well, American Geophysical Union is an organization that does. It's a 501c3 nonprofit that has done a lot of research on Earth, the atmosphere, space, and planetary science. All right, so it's international. It has 62,000 members, over 62,000 members from 144 countries. All right, so it's a professional scientific society that's been around for 100 years now. So, you know, if you have any interest, atmospheric, ocean sciences, space sciences, whatever, go attend. Look up agu.org. Just go to that website, agu.org. All right, closer in, well, maybe not closer in, around that area, there's also a small bodies assessment group. That's just a workshop. If you're interested in like asteroids or comets, so forth, that's early next year, January 14th through the 16th, 2020, in the Pasadena Hilton Hotel in Pasadena, California. This I thought was interesting. This I really might want to go to. Okay, so I'm interested in life on other worlds, right? It turns out there's a conference here. When I say here, I mean around Houston. There's another one. This is called Challenging the Perceptions of the Requirements for Life on Earth and Other Worlds. In other words, this is the Origin of Life conference here in Galveston, Texas, and this is January 19th through the 24th. At the Hotel Galviz, 2024 Seawall Boulevard, which is right next to the beach, by the way. So this is going to integrate research of chemists, biologists, planetary scientists, astronomers, computer scientists, others in the question of how did life begin, or at least on Earth, and other planets. Is there life beyond Earth? How would those life begin? This just seems so interesting. So this is 19th through the 24th, so it's, you know, it's like 19, 20, 21, 20. That's like 5 days. It's pretty cool. Actually, 6 days. Yeah. So, you know, consider attending. All right, in Galveston. All right, And then I gotta say, from the aerospace side, there's some cool conferences coming up too, and I'll briefly go through them. There's a 23rd annual FAA Commercial Space Transportation Conference. That is on Wednesday, January 29th, 2020, to Thursday, January 30th, 20. Okay, so 2 days. This is in Washington D.C. FAA, they have a commercial space transportation department now, and this is cool if you're, doing stuff that like flying spaceships or whatnot. So please attend if you're into that. There's a Small Sat Symposium in Silicon Valley. SmallSat 2020. That is Tuesday, February 4th, all the way to Thursday, February 6th at the Computer History Museum. Imagine that, in Mountain View, California. So check it out. And there's also Aerospace Europe Conference that's later in February 25th to 28th. More details pending there. So that's just a quick run through of all the interesting conferences that I've found that some of you guys, listeners, may be interested in going or at least checking out some of the papers, right? So I believe we are going to have to go on a short little break. When we get back, let's talk about the sun, and maybe even watch a short video about it before we talk more in depth. And then after the sun, talk about spacecrafts that's visiting the sun or using the sun. So, all right.
Growing up as a black kid in New Jersey, all I ever wanted to do was be a pro athlete. All of my role models were black athletes. And every time I would stare out the window and look at the sky and wonder what I'd be in the future, it always had to do with me catching some crazy football and scoring a touchdown. When it came to the point that I was told that I would not be able to play on an organized sports team for the rest of my life, it was something that I really didn't even know how to stomach in the moment. And I remember walking out of my cardiologist's office and just sitting in the hallway and breaking down for a few minutes just because it was something that I just couldn't plan for and couldn't account for. And I realized that in that moment, my entire life was going to be changed. And all of those dreams and hopes and aspirations that I had were going to go out of the window.
Stars are scattered throughout the universe, the one at the center of our solar system plays a special role for us here on Earth. Our sun formed about 4.5 billion years ago in the Milky Way galaxy's Orion Spur. It was born when a cloud of dust and gas, known as a solar nebula, collapsed. And in the middle of this formation, matter condensed into a burning ball of gas that became our sun. The sun's fiery nature, along with a tremendous gravitational pull and an extensive magnetic field, helped it to become the heart of our solar system. The sun can be divided into 6 layers or regions: the corona, the chromosphere, the photosphere, the convective and radiative zones, and the core. In terms of atom count, the sun is about 91% hydrogen, the sun's fuel, 8.9% helium, and 0.1% heavier elements, such as carbon and nitrogen. Due to the sun's extreme temperatures, these elements stay in a gas-like phase called plasma. In the core, temperatures reaching at least 27 million degrees Fahrenheit, combined with the sun's powerful gravity, fuse together hydrogen molecules to create helium. Called thermonuclear fusion, this releases an enormous amount of energy in the form of radiation, electricity, solar wind, and, as we experience on Earth, life-giving heat and light. Such volatility is contained thanks to the sun's tremendous gravity. It's strong enough to hold the solar system intact and is primarily due to the sun's size and mass. Our sun is the largest and most massive object in the solar system. It's more than 100 Earths wide and could theoretically fit all.
So you just saw a little short intro. Oh, before I go on, I'd like to say you're listening to SG2 on Space, episode number 53, where today's topic is on the sun. And so you just saw a little short clip on that. Why don't I read you a poem? Because I also write poetry. Besides talking about space and working in the aerospace field. Among a number of other things. But let's see. So this poem I actually wrote a few years ago. It's called Fusion. And I think, tell me what you think, if you wish. Hydrogen atoms collide and are no more, conjoining in fusion into helium-4. PP chain reactions with nuclear propensity thus are born weightless packets of energy. Photons, we call them, created, destroyed, and created once more, 1,000 times within our solar core, until they reach the photosphere, and with 499 tick-tocks of my watch, they fly across space onto Earth. So how wondrous it is to know this morning gift that we all receive, bright light from silent explosions of a floating reactor in empty space, sitting 100 million miles away. When I describe it like that, it is quite remarkable. At least I think so. The sun is a giant fusion reactor, essentially turning hydrogen into helium with these particular PP chain reactions, right? So, and it is, it apparently takes, I forget exactly how many years, but it takes a very long time for the actual sunlight, for photons, those are particles of light that's produced within the sun, to reach the surface. So it might take, say, 10,000 years for light, because it keeps hitting, getting absorbed and injected and so forth. And so, but when they reach the photosphere, which is the surface of the sun, it only takes about 8 minutes or so for you to feel the sunlight, right, for the sun to hit Earth, which is really cool. All right. So brief aside here, there was for you guys who look up at the stars, there was a recent Mercury transit on November 11th, 2019. That's when the planet Mercury crosses in front of the sun. That doesn't take place very often because Mercury revolves, so close to the sun, right? So the last transit before this is maybe you think that's not so bad. It was May 9th, 2016. Actually, the last one I should say is November 11th, 2019. Before that was May 9th, 2016. Before that was November 8th, 2006. Now, when's the next one? This will take a while. The next will occur on November 13th, 2032. Typical transit lasts a couple hours, right? So, a fun fact, on June 3rd, 2014, the Mars rover Curiosity, which, by the way, is the only remaining rover on Mars that actually works right now, until next year, until NASA lands a Mars rover. Again, Mars lander, and China. June 3rd, 2014, the Mars rover Curiosity observed the planet Mercury transiting the sun. And that marked the first time a planetary transit has been observed by humans from a body that's not on Earth, which is kind of cool. There's obviously also transits on Venus, and so forth. All right. But here, we're not talking about, the reason I'm bringing that up is that you can go online and find cool pictures and don't miss the next one if you miss this one, right? But really, I would like to talk about the actual sun, right? So there's plasma spouts out from the sun. That was some news recently, all right? Now, so the sun is pretty active. It's not just sitting there shining light all the time, all right? So there's regular jets of solar plasma that erupt from the sun, all right? Now, it's one of the greatest mysteries of our time is why the halo of the sun, the corona, which is you typically, when you look at the sun, I don't advise you guys doing that with your naked eye. You might go blind. I am not advocating that, but if you are able to capture an image of the sun with a telescope, that you're not directly looking at, or a solar telescope that blocks out most of the light, you will see that you will see the actual surface of the sun, right? But it turns out that the corona, the stuff around the sun, is actually much hotter than its visible surface. Now, why that is has always been a mystery. All right. So at any given time, about 1 million geysers of plasma dot the chromosphere. And as you can imagine, geyser is something that shoots out of the ground, right? On Earth, we have geysers that shoots out like really hot water out of the ground, right? And minerals. Well, in the sun, you're shooting out plasma, which is not the same thing as gas. It's extremely hot. All right. So these solar specules, S-P-I-C-U-L-E, can get hotter than 180 degrees Fahrenheit or 100,000 degrees Celsius. So we've seen them for about 140 years, but we don't know what's actually creating them. The sun is still a great mystery, all right? Earlier, let me just give you some numbers. I said the visible surface of the sun, that's called photosphere, by the way, that can reach about 10,000 degrees Fahrenheit or 5,500 degrees Celsius. However, the corona, which is the outside thing, can reach 1.7 million degrees Fahrenheit or 1 million degrees Celsius. Or all the way, that's the lower end, to more than 17 million degrees Fahrenheit, which is equivalent to 10 million degrees Celsius. And that's pretty wild, all right? That's a huge difference. So now, as of last week, researchers using the GOOD, G-O-O-D-E, solar telescope at the Big Bear Solar Observatory in California, they have captured images that maybe provide clues how these specules form, all right? So this telescope is the highest resolution solar telescope ever built in the U.S. So you really need a very high resolution telescope to see these specule features, all right? So what did they find? Well, they found that many of them emerged, they were created within a few minutes of the formation of a patch on the photosphere. Remember, photosphere means surface of the sun, with a magnetic field reversed from its surroundings. So for example, specules would erupt from a patch that was mostly, say, magnetized north shortly after it appeared within a region that was mostly magnetized south, or most polarized magnetic south. So maybe they form from effect known as what's known as magnetic reconnection, which is something I would need to do more research on before I tell you guys what that means. Essentially, what that is when, from a very broad perspective, when two magnetic field lines clash, they break each other, they reconnect with each other, and they convert some of that magnetic energy into heat and kinetic energy, thermal energy, all right? And essentially thermal energy. Kinetic energy is thermal energy. So these magnetic reconnections can also cause other phenomenon, larger outbursts such as coronal jets, solar flares, coronal mass ejections. So, the specules are these tiny ones, right? But, it could cause the same phenomenon could cause these bigger eruptions on the sun. Very interesting stuff. So, I'm sure we can discover more, especially with the Parker Solar Probe, which I will talk about shortly. So, in any case, another thing I want to bring up is briefly about. Oh, actually, you know what? Might as well skip this. Let's talk about the fact that. So the Earth magnetic field was recently pummeled by a solar storm, and to the point where you can actually hear the sound. That's right. So this is from the European Space Agency. All right. So the European Space Agency released a recording of frequencies generated as a solar storm collided with the Earth magnetic field, which is pretty darn cool. I think. Anyways, so what are solar storms? I already described that the sun is a pretty active object, right? So solar storms are literally when, there's a storm that happens. So on Earth, you have storms, you have lightning, right? On the sun, you erupt out electrically charged particles, ions, that eject from the sun and hits Earth, okay? It actually goes everywhere. All right, it flies out. So when these particles hit Earth, they come into contact with the planet's magnetic field because we have a rotating liquid iron core, right? So the first region of magnetic field they hit is called the foreshock, and the interaction of these particles with a foreshock causes a release of really complex magnetic waves. So ESA's cluster mission was able to record these magnetic waves as they scatter into these higher frequencies, and you can convert these frequencies into audible signals, and it's pretty darn cool. So when there's no solar particles to contend with, when it's quiet, magnetic waves naturally oscillate on a single frequency, and it just seems like calm and chill, right? Now, when it hits, it's more chaotic. So it is, the sounds are quite complex, and it's because the interactions are quite complex with our magnetic field. All right. So now, why is this really important? Well, space weather, besides from the fact that it's scientifically interesting, it can have a really important impact on Earth, right? Because our magnetic field is our planet's primary means of defense against excess, ions that would otherwise knock out a lot of our electrical equipment, where we'll get a cascade of, charged particles. So a lot of our satellites would be knocked out, our power grids were knocked out. It will suck, basically. You would not have any electricity for a while. So, what can you do, right? So space weather is extremely important. And in fact, I would say, you guys, everyone checks the Weather Channel, right? Maybe not everyone, but, if you're living in certain areas of the country like Houston, you might want to know, okay, is a hurricane coming? What's going on, right? So likewise, checking out space weather, that could affect global. So that's pretty darn important. And so to see what the mood of the sun is, so to say, you can go to NOAA's website, NOAA, which, by the way, also provides data for the Weather Channel and all of that. So that's swpc.noaa.gov. Just a note, if you want to find out, like, hey, is there a solar storm that's going to hit us tomorrow or next week? Well, you will find out if you go there, right? So with that, let's talk about spacecrafts, and I believe I have a guest. You guys may have heard Leonard a few times. He's becoming a regular now, it seems. Are you on, Leonard?
Yeah, I'm here. Hey, Ken, how's it going?
It's going pretty well. Hopefully you heard my riveting talk on some of the sun stuff. So I want to talk about, you actually brought this up, in terms of solar cells and such. But first of all, I want to talk about the Parker Solar Probe. Have you heard? I'm sure you've heard of that, right? And
yeah, it's pretty interesting. It's been making like periodic excursions close to the sun. One of the biggest issues or problems with the solar corona, is why is it as hot as it is? And I still think that that's up in the air, and hopefully this series of excursions to low, the close approach to the sun will give us some opportunity to answer some of those questions. It's been a long-standing issue.
Right. And I mentioned that a few minutes back as well. So just to give everyone a quick background, Parker Solar Probe, or abbreviated PSP, is a NASA spacecraft that was launched in 2018 with a mission of repeatedly probing and making observations of the outer corona of the sun. So it's designed specifically to look at that. And it will be the closest spacecraft to ever approach the sun. It will approach to within 9.86 solar radii. In other words, that's the 9.86 times the radius of the sun. That's about 6.9 million kilometers, or 4.3 million miles from the center of the sun. And by 2025, we will travel a closest approach as fast as 690,000 kilometers per hour, or 430,000 miles per hour, or 0.064% of the speed of light, which is actually going to make it, I believe, the fastest spacecraft ever made, at least for that.
I think so. Yeah, I think by far it would be the fastest human-made object.
Yeah, exactly. So it's going to achieve a number of things. I mean, clearly, closest approach to the sun, fastest human-made object. Those are already hard ones to beat. So, you know, did you I think recently, as far as last week goes, it did 2 close passes to the sun. Leonard, do you know much about that?
One of the interesting things about it is that its orbit is alternating. It's been engineered so that it approaches perihelion, which is the closest approach to the sun, and then comes back out and goes all the way back up to Venus. So the orbit is so eccentric. It's such a narrow width orbit that it alternates between the orbit of Venus and very close to the sun.
Yep.
The reason they're doing that is they're using Venus as sort of the propulsion process. So it's using a gravitational assist from Venus.
Yeah.
It has a complement. I think about a complement of sensors on it, including a magnetometer, which I think is pretty important, and plasma probes and so forth.
So you're right.
But
Okay,
you already went all over through that?
No, I haven't. I'm just saying they have. I'm looking at what they have. This is not from my memory. This is from looking at a computer screen. So they have something called electromagnetic fields investigation. So it has 5 major experiments / investigations. So the 5 of them are electromagnetic fields investigation, otherwise called fields. So this investigation makes direct measurements of the electromagnetic fields around the sun, and it has 2 fluxgate magnetometers, a search coil magnetometer, and 5 plasma voltage sensors. So is that what you're talking about?
Yeah.
Okay. Then the other ones I might as well tell everybody. There's another investigation called Integrated Science Investigation of the Sun. In other words, ISOIS. And these measure energetic electrons, protons, and heavy ions. So, and they have 2 independent energetic particle instruments, one for studying higher energy particles and one studying lower energy particles. Then the third investigation is called Wide Field Imager for Solar Probe, in other words, WISPR, WISPR. And these are optical telescopes, and, well, they take pictures of the corona and the inner heliosphere. The fourth one is called Solar Wind Electrons Alpha and Protons, SWEAP, SWEAP. And this investigation counts the electrons, protons, helium ions, and measure the properties, like velocity, density, temperature. And its instruments are solar probe analyzers, solar probe cup. Okay, so solar probe analyzer are 2 electrostatic analyzers, and the cup is a Faraday cup. And then the last investigation is the heliospheric origins with Solar Probe Plus. Shorthand is Helios PP. And this is this is more of a, I guess, just a modeling investigation. I'm not too sure. Not quite sure what that instrumentation that has. But yeah, you can see there's a suite of instruments there. And Leonard, I do find it interesting that it constantly uses gravity assess of Venus.
Another thing that maybe your listeners would be interested in is the nature of the plasma that's coming off of the sun. A lot of people hear about this. But it's a fluid, it's like a gaseous fluid that's coming out, but it's magnetized, and that magnetic field has a very profound effect on the plasma because it's electrically conducting, and so that plasma flies off of the sun and goes all the way out into the interplanetary medium. It passes the Earth. It's responsible for the aurora that you probably talked about in the past. It interacts with the atmospheres of the planets. it comes off in a spiral because it retains some of the rotation of the sun, and so that entire gaseous atmosphere of the sun is pouring away all the time.
That's interesting.
It's interesting. It as I say, the field of the sun is disordered during periods when the sun goes through a cycle. There's a 11-year cycle. So everybody knows that, but it's actually a 22-year cycle because the cycle starts with the magnetic field of the sun in a north-south orientation, and then during the 11-year cycle, that gradually reverses, and so that the North Pole is then the South Pole, and then it reverses again. So the 11-year cycle is actually, to go through a complete cycle, is really 22 years. And the sunspots are involved with that.
The cool, yeah, huh? That's where are we right now? Are we in a solar minimum, maximum? Where
I think
are we?
we're approaching. I think we should be approaching a solar maximum at this point, but the sun has gone into a peculiar phase in the last couple cycles where we have very, very few sunspots, and that happens. That appears to happen every few centuries. The sunspots have been observed since the early 17th century. Galileo was the first to observe them, and people were looking for them for a long time. They seem to have disappeared for a few hundred years during the, I believe, 17th century, for a period of about 80 years. And we know they disappeared because people wrote about them and they were looking for them and they didn't find them. And then they started up again. And we may be going into a phase into that same kind of regime again.
Why, Leonard, do you happen to know why these sunspots disappeared and why there's so few of them now?
Well, I think that the nature of a rotating fluid, rotating magnetized fluid, planetary scale body, there's some unity in the physics because, the Earth has a magnetic field, right?
Yes.
And many of the planets have magnetic fields. And what they all have in common is electrically conducting body that's rotating, and the magnetic field actually acts like almost like a rubber band type of thing, and it gets bound up, and exhibits a pressure associated with the field, and so those magnetic field lines that get wrapped up in the rotating body. We have to reference some cool imagery that I'm sure we could Google up. Those will emerge from the surface and form little loops. And some of you have seen images of the sun in eclipse where these streamers are coming out.
Yes,
and
those are so cool.
The feet of those streamers are located at usually at sunspots. And so I don't think the physics is really completely understood in the way that we would really like to understand it. But like I said, there is some unity in the overall notion that there's a rotating body and rotating fluid. The Earth has a fluid core and it's rotating around, and the same physics that create the magnetic field of the Earth is operating at the sun. The sun is of a different scale, and it exhibits a periodicity where its field reverses every 22 years. You go through a complete cycle.
Right.
Some of you may know that the Earth's magnetic field also reverses, but not periodically. So there's a quasi-chaotic mathematics associated with that at some level. So we're in a regime. The the Earth has a magnetic field that reverses every few thousand years, but at more or less random intervals, whereas the sun is in a periodic region
reversal.
of
Yeah.
whatever that chaotic attractor process is.
Yeah,
So,
this is all really interesting. Leonard, and for the rest of the viewers, we are going to have to take a short little break. When we come back, Leonard, I want to talk to you about solar sails. That's something. Solar sails?
Solar sails, yeah.
Sails, yes. Riding on the sun, or light, really.
We'll be selling suns, so we're going to have a sale.
Yeah, we're going to tell you about selling our sun, all right, once we come back. So stay tuned.
That should keep people tuned in.
When we come back, we have 2 questions from the audience that they have posed to Shen and to Leonard. So let's hear from the audience when we come back, and thank you guys for tuning in to SG2 on Space.
Awesome.
Okay, can Leonard hear me?
Yeah, I can. He can. He's speaking of himself in the third person.
What are the questions?
I don't know.
Man, you still here? Go on and subscribe.
Get into action. Yo, we back at it again, baby.
What?
Get into action.
3.
Get into action.
Tell me what is the deal, tell me what is the deal.
So I challenge you today to start strong.
I ain't seen you.
Get in the action.
Tell me what is the deal. Cause I'm calling for you.
Get into action.
Can you feel that? Yeah. See, I'm calling for you. Can you feel that? Yeah. See, I'm calling for you. Can you feel that? Yeah. See, I'm calling for you.
When the 7 trumpets sound, we gon' start the revolution. When we turn up, we shut it down. We are skywalkers. This feels of my Kabbalah, illuminated properly in sight. Shows the man in universe and the creator's gift of life. When the earth collides with every piece of star from afar, there's a higher probability to find out where we are. Trapped in time and space, lost in this dimension. 7 sins committed daily. Never did I fail to mention this the rapture. I capture every piece of star power with this mic to evolve and conquer all. Collapse in darkness with this light. I bear to witness any slightest hint of changing.
We are back. You're listening to SG2 on Space, episode number 53, where we're talking about the sun, solar physics, and soon going to tell you about selling the sun. But first of all, we got also we got Leonard Kramer online, on the phone, I mean, who is a aerospace engineer and artist and does a bunch of other stuff, if I haven't introduced you already. So, Leonard, you ready for the questions too?
I am ready.
All right, what's the question?
The first question is posed by Miles. Miles wants to know a couple of things. Can we use high-powered electromagnets in orbit to reduce the impact of the sun's energy?
That's the first question?
And are photons affected by magnetic fields?
Leonard, you want to answer this?
Photons are not affected by magnetic fields.
Yes.
They are massless, chargeless particles. In order to be affected by a magnetic field, the particle would have to have an electric charge.
Yeah, that makes a lot of sense to me. The first one, I'm not quite sure what that means. So
we can't use high-powered electromagnets in orbits to reduce the impact of the sun's energy.
Yeah. Okay. So let's put it this way. I'm going to see if I can take this question. So in terms of the energy from the sun, yeah, some of it are charged particles. So with those, if you, I guess, have some kind of electromagnet, you could possibly deflect it. I mean, that's how Earth's magnetic field works, right? So it's deflecting a lot of the charged particles from the sun. So if we make some kind of human-made version of that, then we can do the same thing, but I think that would require a massive engineering effort. So I'm not exactly sure how that could be implemented, but we could do it.
Well, the question is talking about photons, but I think Miles probably means the charged particles, the charged particles from the sun.
Right.
We're not really we are really not they don't really pose any great threat to us, and it's not clear to me that there would be better ways of handling the electric discharge effects that we sometimes observe or sometimes have from solar events.
Okay. For the sake of time, let's move on to the next question.
This question is posed by Stacia. Sorry if I mispronounced. She wants to know how the discussion earlier affects our poles. So,
the discussion earlier affects our poles?
Mm-hmm. The North and South poles. Or does it, I guess?
Which discussion?
The discussion of the sun and its movements that you guys had towards, I guess, the last 5 to 10 minutes.
I wonder if that means well, let me ask you this, Leonard. So for the sun, do we know why the field reverses in such an orderly manner?
I was trying to express the uncertainty about that. I think we don't quite know. There's some work by a scientist named Ken Shatton at Goddard Space Flight Center. I think it's Schatten, and he's written some papers that have some modeling, that describe modeling that replicates the reversals of the sun's and as far as affecting the Earth's, I think Stasia's question has to know. She wants to know how all of this affects the Earth's pole. I don't think that we have anything to worry about. I don't think that I can't think of any physics that would couple the sun's magnetic field to the Earth's magnetic field in a way that caused the Earth's field to reverse. I think the effects that are going on are internal, non-linear mechanical things that are going on inside the Earth and also in the sun.
Okay, that makes a lot of sense. Okay, I think we answered the questions as they are right now. Anything else, you can just post it on Facebook or the YouTube, and we can answer in greater detail. Now, I typically, as everyone who watches the show knows, I like to talk about ETs now with the last few minutes. But today I want to actually kind of segue into it, since Leonard, you brought up the interesting fact about Oumuamua, which I've talked about on this show before in the past as well. And actually, before that, let's talk about solar cells briefly. So, Leonard, what is a solar cell?
A solar sail. It's a large area of fabric or material that reflects solar photons from a light source like the sun, and can be used as a source of propulsion. So the idea is you can sail in space. Now, a lot of times when you read about this, journalists in particular will talk about the solar wind,
right?
And I want to be clear, it's not the solar wind. It's actually the sunlight that causes the pressure, and it's very interesting physics that contributes to that.
So, as I was telling people earlier, the sun light carries it with it momentum, and so it can actually cause things to move when it hits something, and you would need a large area because these light particles are pretty their energy, each individual light particle photon doesn't carry that much energy, so you need to maximize the area and make sure it's reflective as well. So literally you're writing light is pushing you. Okay. And for you guys' reference, in previous episodes, I have talked about how Planetary Society built their second light sail and launched it recently. Planetary Society is the largest, I think one of the largest nonprofits dedicated to promoting science education and engaging the public and so forth. So you can check it out. You can look up planetary.org and look up light sail. NASA also has plans for light sails. Leonard, I don't know if you may know this, but I read something like about there's something called the Near Earth Asteroid Scout. Have you heard of that?
Yes, I have. The Japanese Space Agency has quite an advanced program also to fly solar sails. I think it's called Iconos.
I think it's called Icaros, Ikaros. Yeah, interplanetary kite craft accelerated by radiation of the sun. And that one it actually was very successful, and it passed Venus on December 8th, 2010. I think it's probably still going.
Yes, I think so. Last I read.
Yeah, I think it's still going, but I see that at the end of the mission, the last contact was on May 20th, 2015. But I'm pretty sure the spacecraft itself is still flying, so powered by the sun. Okay, I wanna go into this alien stuff because you mentioned Oumuamua, which for people's reference, it is, I believe, the first extraterrestrial object that entered our solar system and then left. And had a really weird shape that looked like a pencil. I mean, really long rod, basically. So Leonard, I'm not. You may already have heard of this, but there was a paper out there by this Harvard astronomer and his grad student or somebody, or actually no, somebody from the Harvard Smithsonian Center for Astrophysics, and another Harvard astronomer. They published this paper that hypothesized it might be basically a spacecraft, alien spacecraft.
Right.
Have you heard about that?
Look, I've drawn the ire of some of my space physics colleagues by saying that I think that it's a higher probability that it's an alien spacecraft than anything that we've seen. There are so many things that I can't understand about that object that are completely unprecedented. That that the idea that it's a technological thing, some product of technology is not zero.
Right.
And that, I'm serious about that. I'm not playing games. It does have some characteristics. There were problems with the orbit. Apparently it was changing the energy of the orbit while it was on closest approach to the sun in ways that we can't really model or understand in terms of most comets will change their orbit, but we observe venting. In other words, material will explode because of it heated up, and we couldn't see anything like that. It has a peculiar color. Its shape apparently is 10 times longer than it is wide, although I have to say I'm skeptical about the evidence for that. All of the popular articles show this long cigar-shaped thing, but the actual images of it the actual real images are just take up a few pixels, and the evidence that it has that shape is problematic. It's questionable, or it could be challenged. But I'm excited. I was excited about it when I first learned about it. However, just a few months ago, another comet, just a regular comet, came in at a very high high speed also, and it also is a extraterrestrial visitor from the interstellar space. So part of the reason we're seeing them is probably because our sensor network is improving, and we're better able to see these things. It could be they're coming all the time, and these are just the first two that we've observed.
Right. I mean, if we see another weird object come in as well, then that'd be interesting. So I wanted to bring this Oumuamua object because this particular paper that I'm talking about actually said there was a possibility that this so-called asteroid or spacecraft was sailing on solar radiation, and it was discounting that because it said, if it was purely propelled by solar radiation, then it would have to be less than a millimeter thick and hundreds of meters long. So
right, I read the paper. Yeah, so their thinking is that maybe it's a solar sail, or it's hollow, or something,
right,
something like that. It's it doesn't have the mass that we would assume it has. It's cool stuff.
Yeah, it is. So you can go ahead and read the paper for people interested. It's called "Could Solar Radiation Pressure Explain Oumuamua's Peculiar Acceleration?" Because that's one of the great mysteries, right? Why it increased its velocity without having any known physical cause. So, any case, all right. Leonard, did you also hear that there's this change of topic because might as well talk about aliens? There was the scientist who said that he thinks there's photos taken by Curiosity and other rovers that indicates that there's like Mars bugs,
little insects and lizards and things like that.
Yep. This Ohio scientist William Ramasur. I was like, that's interesting. I mean, like you drew this picture. There's looks like, I mean, it's like, here's a leg, here's an eye, here's a thorax, here's an abdomen, here's a head and legs.
A wasp on Mars.
On Mars, exactly. And what do you think? I mean, obviously, the mainstream science says no.
Well,
could that even be possible?
Well, if they're fossils, it's possible. I don't think that it's possible if they're living organisms. If they were living organisms, they wouldn't look. I wouldn't imagine that they would look anything like terrestrial organisms because the environment is so much different and it's extremely cold. And you know the whole Megillah there on that. But if they're fossils, I don't know. I wasn't impressed with the photograph.
Neither was I. Honestly, I don't think it was a very solid proof of that. So, hopefully we will. I don't know. And yeah, but you're right. Who knows? It might be fossils. We don't know.
When the Curiosity rover, those dual rovers landed originally in 2004, 2003. There were these high resolution images of spheres. These little. They started calling them blueberries that were in the strata. You can Google that. And I remember all of us were looking real close at that, going, "Wow, those are perfect spheres, and they're all over the place." And I think that they've explained that as a natural accretion process. In other words, they understand the chemistry of what formed those things. But I thought those are fossils. Those look like little artificial, not artificial, but they look like fossils of something.
Yeah, that's really, that they're like perfect spheres now that I see them. I mean, they have some explanations, but it's not conclusive. They would need to have some higher resolution sensors to confirm. So yeah, we only have about a minute or so left, or rather, not even that. It seems like.
Oh no.
Well, So,
went by
Leonard,
so fast.
what?
It went by so fast.
I know. You just kept talking. Okay.
Sorry.
But anyways, thank you, Leonard, for your time. So you guys have been listening to episode number 53, SG2 on Space, where we talk about solar physics, solar sails, other strange stuff. And this is your host, Shen Gut. So follow me, facebook.com/The Shen Show, or go on YouTube. And please support me at patreon.com/SG2 on space. That's patreon.com/SG2 on space. So thank you, everyone. And don't forget, what is the catchphrase?
Keep looking up for. Make sure you look.
Look up, because you never know what you will see.
You never know what you might see.
That works, Leonard. Thanks for that. Okay. All right, bye, everyone.
Peace, it's Brother Atum Ra, and you tuned in to Action One Network.